Hey everyone, it's Miss Spivey. Today we're going to be talking about the beginning of Unit 2, specifically the parts of the atom. So we're going to be looking specifically at parts of an atom, ions, isotopes. We're going to be calculating the number of protons, neutrons, and electrons that a nuclide has. So in order to participate in this lecture, you do need your Unit 2 book. You're also going to need a periodic table, okay, and maybe a calculator. All right, so hopefully this is a complete review of things that you've done as soon as, like, maybe the last time you saw this was in biology, depending on your teacher. Definitely you should have covered this some in middle school. So here we go. Some big vocabulary words that you have to know this unit. A lot of them can be interchanged. So an element or an atom. I always refer to it as our fundamental unit of matter. It cannot be broken down without losing its identity. Okay? So, can't break down. So, let's talk about your periodic table for a second. So, get your periodic table out in front of you. Your periodic table has probably 114 elements on it. Now, the periodic table has even grown to where all of the ones there at the bottom now have names, okay? Because as hopefully you've realized by now, science is always changing. We're always finding out new things. But I want to talk really quickly about what's contained for you, like on a basic square on the periodic table. So I'm just going to pick a box. Okay, let's look at zinc. Zn. Everybody finds zinc. Okay. Zinc is an example of an atom. Okay. It is an element. There's only one type of atom present in zinc. So on this box for the periodic table, there are some pretty important aspects. Okay. This top number here is our atomic number. Sorry about that. This top number here is the atomic number. Sorry about that. This top number here is the atomic number. Okay. And this bottom number here is the atomic mass. Okay. So both of these values are going to help us figure out how many parts of the atom there are. So within an atom, we are going to have protons, which I abbreviate with a P, neutrons, and electrons. Okay. Protons are located in the nucleus. They have mass and also a +1 charge. Neutrons are also in the nucleus. They also have mass and they have no charge. They are neutral. Electrons are located in the electron cloud. For our purposes in Chem 1, they have no significant mass, but they do have a charge of -1. Okay, so just so we're clear here, the mass of our atom is contained within the nucleus. Okay, so there's our mass. So this atomic mass number is going to give us our number of protons and our number of neutrons. Okay, now the atomic number is the most important number on the periodic table. This atomic number tells us the number of protons, which is the identity of the atom. Okay, so zinc has 30 protons, but gallium has 31. Copper has 29. When you change the number of protons, you change the atom you're working with. Okay, so this right here that I'm putting a box around, our atomic number and our atomic mass, this is a basic fundamental truth of chemistry. Okay, the atomic number will always tell you the number of protons. The atomic mass will always equal your protons plus your neutrons. Okay, so one big distinction that we need to go over is the fact that atoms are naturally neutral. Okay, Neutral means that the positive charges coming from the protons are equal to our negative charges from the electrons. Okay, sorry, that's the bell, if you hear it. Okay, so the protons equal the electrons. So that's not always going to be the case, but it will work for atoms. Okay, so the other big fundamental truths, though, that we know, the atomic number gives us the number of protons. To find our neutrons, we're going to subtract the mass number minus the atomic number. Okay, so good news is you will always be given a periodic table. Okay, always. No matter what test, the SOL test, a unit test, whatever, you get a periodic table. But we also need to make sure that we understand how to look at an atom that's written in shorthand notation. Sometimes this is called a nuclide. Okay, so let me write up a couple. Okay, so with the symbols that I have down at the bottom of the screen, down here at the bottom of my screen, we have shorthand notation. One number is the mass number, one number is the atomic number, and you should be able to look at your periodic table and guess which is which. So take a minute, pause the video, and figure out if the top number is the atomic number or the mass number. All right, hopefully you pause the video and you realize that this top number here is our mass number, okay, and that this bottom number here is the atomic number, okay. So that's the case for all of these, all the time. I want to steer you away from memorizing when I can, just because, I mean, the less you have to memorize, the more you actually know. So you will always have the periodic table. Why not take a look and make sure that you're verifying which one's the mass, which one's the atomic before you get going. Okay, so let's look at these atoms that I have here and let's find the number of protons, neutrons, and electrons. Okay, so I know that helium has 2 protons because that is our atomic number. Okay, I know that because this is an atom and there's no charge, that also means that I have 2 electrons. Now, to find my neutrons, I'm going to take the mass number, 4 minus 2, and that will give me 2 neutrons. All right? Let's look at aluminum. Aluminum always has 13 protons. That's what makes it aluminum. Because this is neutral, there's no charge in the up-hand corner. I also have 13 electrons, and I'm still going to subtract to find my neutrons. So 27 minus 13 is going to give us 14. Everybody with me? So now we look at chlorine and you're like, oh man, they didn't give it. I'm just going to have to guess what the atomic number is. Wrong. Look at your periodic table. So chlorine very obviously has an atomic number of 17. All right. So when we're looking for our number of protons, we will always look at the atomic number. That is always the case. So I have 17. There's no charge on my chlorine, and so I'm going to also have 17 electrons. 36 minus 17 gives me 19 neutrons. Okay, again, hopefully this is 100% a review from biology. Okay, and I want to remind you one more time. This is always true. The atomic number will always equal your number of protons, and that always gives you the identity of your atom. The atomic mass will always equal the number of protons plus the number of neutrons. Okay, so let me add a slide. All right, so we covered atoms, and we reviewed again that atoms are neutral. All right, we talked about how atoms are. All right, so we already covered the fact that atoms are neutral. Their protons equal the electrons. So now we're going to talk about ions, okay? Ions, in an ion, the number of electrons change. Okay, so that means that we have a charge on our atom, on our ion. So there are 2 types of ions, cation and anions. Okay, Cations are positive, like cats have paws. Okay. Now you have to kind of think about why cations are positive. They are losing electrons. Anions are negative because they add electrons. So some people like to try to think that just because they see the plus sign, we add on electrons. But that's not true. You have to think about the fact that electrons are negative. Okay? Because electrons are negative, when you lose the negative charges, your protons, you will have more positive charges now. Okay, so the positive charge wins. Whereas when you add on negative charges and you have more negatives, then your overall substance becomes negative. Okay, so let's look at a couple of examples. In a couple of days, we're going to learn how to tell, we can predict the ions that some of our atoms form. So if I have Mg, all right, so here are some more shorthand notation that we're going to look at. So let's look at magnesium. We're going to find the number of protons, neutrons, and electrons. So hopefully you know by now, protons always come for the atomic number. It wasn't given to you this time, but we can look at the periodic table and we see very clearly that magnesium has an atomic number of 12. Okay, we still subtract to find our neutrons. 24 minus 12 gives me 12. But now let's look at our electrons. My protons and my electrons are not equal because of this positive 2 charge. Okay, this is a cation, and so that tells me that I have lost electrons, specifically 2 of them. So magnesium had 12 electrons, it lost 2, and so that means that I now have 10. So you can very clearly see I have 12 positives, 10 negatives. That's where the positive 2 charge comes from. Okay. Now let's look at iron. Okay, iron always has an atomic number of 26. That means it will always have 26 protons. If it didn't have 26 protons, it wouldn't be iron. Okay, I'm still going to subtract to find my neutrons. So 55 minus 26 gives me 29 neutrons. And now again, let's look at our charge here. I have a charge, that means my electrons are different. I have lost 3. So I had 26 electrons, I lost 3, and so I have 23 electrons now. Okay, I know that I started with 26 electrons because remember, atoms are neutral. They naturally exist in neutral states. But now we're working with ions. Okay, last example, let's look at oxygen. Oxygen will always have 8 protons, always. 16 minus 8 gives me 8 neutrons. And so now I have a negative charge. So that means that I have an anion. So now I'm going to add negative charges on. So I had 8, I've added on 2, and now I have 10. So this is why I have an overall negative charge, because I have more negatives. Okay? So atoms are neutral. Ions have a charge because our electrons change. All right. Now the last big vocabulary word that we need to go over is an isotope. Okay. So in an isotope, isotopes are much more abundant than you would think. Okay. In an isotope, the neutrons change. Now, you still have the same identity, but some isotopes will be heavy or light, depending on the number of neutrons. Okay, so good news is isotopes will always give you a unique mass number. So we've seen like uranium-235. It's giving you the mass number that it wants you to work with. Another way that this is also represented is in this type of notation. Okay, so it's very important that you realize that this 235 isn't minus 235. It's actually a mass number. Okay, so let's look at Pu 244 and Pu 241. We're looking for protons, neutrons, electrons. So don't be ashamed of having to hunt and peck on the periodic table. Okay, everybody take a look, find Pu. Pu is at the very bottom. It's actually number 94, plutonium. Okay, so when I'm trying to find the number of protons, neutrons, electrons, the easiest one to always find first is the protons. So 94 protons in plutonium 244. There's no charge on our plutonium symbol that we see like we were working with. So that also means I have 94 electrons. And just like we were doing before, mass number minus the atomic number is going to give me my number of neutrons, which is 150. Okay, so nothing's changed about our method. The only thing that's a little bit different is now we just have to know that this is a mass number, the 244. So take a guess. What do you think will be the same between plutonium 241? I hope you said the protons, definitely. That's what makes it plutonium. And the electrons. Okay, so 241 minus 94 is now going to give us 147 neutrons. So plutonium 244 is a little bit heavier because it has 150 neutrons, whereas plutonium 241 only has 147. Okay, so just as a quick little recap. Okay, atom, ion, isotope. Okay, the atomic number always gives you the number of protons. Okay, so that's true all the way across. Okay, we will always have the number of neutrons is going to be equal to the mass number minus the atomic number. It's the same all the way across. Isotopes, you might just be given your mass number in a different format. Okay? Ions, in an atom, your protons equal your electrons. But with ions, we're now going to have cations and anions. So it'd be like magnesium or oxygen. Okay, and so that means that you have to pay attention to whether or not we gained or lost electrons. Okay, isotopes can also have charges, but now you just have to be able to apply all of these basic, very basic definitions. Okay, so in order to do that, in your Unit 2 book, the best worksheet to be able to mix it all up and apply all of the skills that we've covered in this lecture, go to page 3 and 4 in your Unit 2 book. Complete them. Email your teacher to see if you got them right. Come see us for tutoring. And I hope you are enjoying chemistry so far. Thank you for working hard. Hopefully this isn't bad.